This video talks about resonance structures and the idea of formal charge and how we can use formal charge to differentiate between different Lewis structures for a molecule to decide which of them is better. And we'll talk about resonance first. So here are two resonance structures for the bicarbonate ion. And to talk about resonance, we're going to focus on the CO bonds that don't have a hydrogen attached. So these two CO bonds. And what these Lewis structures suggest is that there's one double bond that would be shorter and stronger. And that there's one double bond, or one single bond that is longer and weaker. That is, you would expect those two bonds to have different properties. But if you measure those two bonds experimentally, they are the same. There's no difference between those two bonds when you experimentally measure how short they are or how long they are. So how do we draw Lewis structures to convey the idea that those two molecules are the same? What we do is take both of those Lewis structures and put a double-ended arrow between them. And we call those combined Lewis structures resonance structures, and they convey the idea that no one Lewis structure is correct, but that the actual molecule is a combination of those two Lewis structures. So the properties aren't depicted by one individual Lewis structure, not by one single bond and by one double bond, but by a combination of those two. And lots of molecules will show resonance structures. So now, let's move on to the idea of formal charge. And formal charge is something that we calculate to differentiate between the different Lewis structures for an atom. So we'll focus on the bicarbonate ion again, and we're going to calculate the formal charges on the three oxygens involved, which we will just label A, B, and C. And we're going to calculate the formal charges on them just to show how to calculate formal charge. So when you calculate formal charge, the formal charge is the difference between the electrons that an atom has as a neutral atom on its own and the electrons that it has access to in the molecule. And the electrons that an atom has access to in a molecule are all of the electrons that show up as lone pairs and half of the bonding atoms. So let's take oxygen atom A. As a neutral atom, right, oxygen's in group 6. It's in group 6, so it has 6 electrons as a neutral atom. In the molecule, it has 4 electrons from the 2 lone pairs, plus it has 2 single bonds. It gets 1 electron from each of those for a total of 6 electrons in the molecule, so it's got a formal charge of 0. If we look at oxygen atom B as a neutral atom, right, it's still oxygen, still in group 6, so it's got 6 valence electrons as a neutral atom. In the molecule, it's got 4 electrons from the 2 lone pairs, plus 2 electrons from half of the double bond, right? The double bond constitutes 4 electrons, half of those go to the 1 oxygen, so it's got 6 electrons in the molecule, so it also has a formal charge of 0. And now, if we look at oxygen atom C as a neutral atom, it's got 6 valence electrons. In the molecule, it has 6 electrons from the 3 lone pairs plus half of the bonding electrons, so it's got a single bond. That's 2 electrons. Half of them go to that oxygen, so it's got 7 electrons in the molecule, so it's got a formal charge of -1. So there are the formal charges for those 3 oxygen atoms in the bicarbonate ion. That's just how to calculate them. We'll talk about how to use that in a minute. So, how do formal charges help us choose between Lewis structures? To do that, there are a couple of rules that we have to keep in mind. One is that the total of the formal charges that you put on the atoms in a molecule or an ion have to add up to the total charge on that molecule or ion. So if it's a molecule where there's no charge, all of the total charges have to add up to 0. And if it's an ion, a polyatomic ion, the charges, those total formal charges, have to add up to whatever the charge on that ion is. So if you go back to the bicarbonate ion, one of those oxygens had a formal charge of -1, and that's the charge on the ion. The carbon and the hydrogen both had formal charges of 0, we just didn't calculate them. So that's the first thing. The total formal charges have to add up to what you know about the molecule or the ion. In a molecule, when you're deciding between resonance structures, a resonance structure with no formal charges is preferred over one where there are some non-zero formal charges. So if you have a molecule with no formal charges and another molecule where you've got formal charges of +1 and -1, the one with no formal charges, or where all the formal charges are 0, is the preferred Lewis structure. Lower is always better. And with that, lower formal charges are preferred to higher formal charges. So a molecule with formal charges of +1 and -1 is more preferred than a molecule with formal charges of +2 and -2, sticking with the lower is better theme. And then adjacent like charges are never preferred, right? So if you have a molecule where 2 adjacent atoms are both +1 or both -1, those 2 adjacent like charges are very much unpreferred, and that's probably not going to be the best Lewis structure you can draw. And finally, when you're making decisions about where to put formal charges, the atoms with higher electronegativities should have a more negative formal charge. They'll have a higher tendency to pull electrons toward them, and as a result, have more negative formal charges. Now, let's look at how we can use formal charges to decide between Lewis structures. So what we're going to do is calculate all the formal charges on all of the atoms in this molecule and use them to decide which of these Lewis structures is best. So here are 3 different Lewis structures for the molecule ClO and O2. And what we want to decide is which of them is better. And the only way to do that is to calculate the formal charges on all of the atoms in the molecule. So we'll start with the first molecule. If we look at the first chlorine, chlorine has got 7 electrons as a neutral atom, and it's got 6 electrons in this molecule. So it's got a formal charge of +1. The oxygen in the middle, oxygen's got 6 valence electrons as a neutral atom. It's got 5 electrons in this Lewis structure, so it's got a formal charge, also of +1. The nitrogen atom has access to 5 electrons in this molecule. It's got 5 electrons as a neutral atom, so the formal charge on that nitrogen is 0. And if we look at the oxygen's got 6 electrons as a neutral atom. In this molecule, it's got 7 electrons, so that formal charge is -1. And that's true for both oxygens, right? So the formal charges add up to 0. We have 2 +1s and 2 -1s. And those are all of those formal charges. Now let's look at the second molecule. The chlorine has a formal charge of 0. The oxygen has a formal charge of +1. The nitrogen atom has a formal charge of -1. And of plus 1. And each of these oxygens, just as in the other Lewis structure, each oxygen has a formal charge of minus 1. And now let's look at this Lewis structure. The chlorine has a formal charge of 0. This oxygen has a formal charge of 0. Nitrogen has a formal charge of plus 1. The top oxygen has a formal charge of 0, and the lower oxygen has a formal charge of minus 1. So if you look at these three molecules, the Lewis structure that's best is this one, because it has the fewest formal charges. So when you're using formal charges to decide which Lewis structure is best, the only thing you can do is determine the formal charges on all of the atoms in the Lewis structure, and then look back at the rules for formal charges and decide which Lewis structure is best.